Ok.
Bienvenido a la segunda parte de esta segunda sesión y bueno, comenzamos. Ana.
Okay, the next team is the PI is Ana Ulla. Good to see you again. And the speaker is going to be Thach Savary from the USA, from the University of Delaware. Is the University of Delaware? Yes. Welcome. Yeah, you can just explain your project in 10 minutes, and in the rest 10 minutes we can try to help you with the observation. You can ask anything in English, of course, that if you want in Spanish.
Yo.
It's been a while since I've had to speak Spanish, so
So you know Spanish.
yes, from high school, but it's
Yeah,
been a
this
while.
is good. This is good.
Okay, and then when you want, you can begin with the exposition.
Thank you.
Do you prefer to share your window or?
Yes, give me.
Yeah.
Okay, perfect.
Yes, is that you guys able to see that?
Yeah.
Okay, great. Need that one. So, why is it? There we go. Sorry. So this project is called Illuminating the Dust, which is probing G2938 with multi-wavelength photometry using panic specifically to get infrared observations. So here is a nice artist rendition of what G2938 is thought to look like with its nice debris disk around a pulsating white dwarf. So here is a map of the different telescopes that we have gotten time for what is called the Whole Earth Telescope campaign. So here the pinkish orange circles represent optical time, and then these purple squares represent infrared time. So we have Kaha here, and then we are expecting about 40 telescopes and over 200 nights of observations as part of the whole 2 weeks of this campaign. So here's a picture of G2938's pulsations. So we can see that it pulsates. It's a multi-periodic G mode pulsator as a white dwarf. So it's not changing size, but it is changing like brightness as we are observing it throughout the night. And so that is why for this project we want a relative photometry to get a light curve throughout the entire night that we can see G2938 is the goal. So we can see here the pulsations throughout one night. You can see how it's about, it's a very large amplitude pulsator, about, I think it's 30% change. And then this right window is just showing how we want multiple nights of observations because it limits what is called aliasing, which is like introduced noise and artifacts from the fact that from one single site you can only observe for maybe 6 to 8 hours in a given night, depending on when exactly you're looking at the object in the year. And so that's going to inherently introduce artificial pulsation, because when you stop observing, that is a very hard cutoff, and then you start observing, that's a very hard cutoff, and so that can introduce a pulsation. So having multiple nights of observations as well as night observations from other telescopes can limit that very hard introduced pulsation, which makes it easier to actually identify and explore the pulsations that we see in the true data of G29. And then I wanted to go over real quickly what we want K-band photometry specifically as part of this project. So as the artist rendition showed, G2938 is a white dwarf with a debris disk, and recent work in 2024 led by Ted von Hippel actually showed that when observing the debris disk out in infrared out to like 2.5 microns and a little bit longer, you can actually see that the debris disk is reprocessing the photospheric pulsations from the white dwarf itself. And so that means we need, so we want infrared observations to actually get imaging of this photosphere reprocessing by the debris disk. And then we specifically want K-band because, as you can see here, the K-band is going to be the strongest excess compared to the white dwarf SED. So that means it has the most light that is coming from the debris disk itself. But so this also requires our time constraint for these observations because G2938 has a rapidly changing pulsation structure. And so if we want to be able to match pulsations in the optical to those seen in the infrared, they have to be taken concurrently, which is why we had a very strict date limitation in when we wanted these observations to be taken, so that we could one, increase the amount of infrared coverage we had by having as many telescopes observe G2938 in this 4-day period that from the 17th through the 20th, 21st. But also we needed to make sure that the optical time could actually be lined up to be concurrent with the infrared data, so we could actually explore what is going on in the infrared and in the debris disk. So then just some quick description of our proposed panic K-band photometry. So I saw that we've actually gotten 4 half nights now based on the schedule you shared earlier, which is actually even better because it increases our time base, which will give us a better frequency resolution, which would be very great. So now it goes from the 17th to the 20th. And then G29 has a K-band magnitude of 12.6. So it is actually quite bright. And then it's going to be above 30 degrees from sunset until 3:30 a.m. So it's a very large window to observe. So we want continuous photometry using of G2938 using the panic K filter, using the CTN RS readout mode. So we want this continuous photometry because G2938's pulsations are on the order of 300 seconds to 1,000-ish seconds. And so having individual exposures that are on the order of 5 to 10 seconds will allow us to really sample those pulsations extremely well and get the full pulsational light curve throughout the night. So with these panic exposures, we initially using the time calculator went about the idea of using 10-second exposures made with 10-second frame exposures with an exposure made of 3 frames in total for 38 seconds. Although I was messing with the OT program yesterday or 2 days ago, and I saw that I can't actually do 10 seconds. I have to do the maximum time it would allow me was 8.7. However, I did check using the panic ETC, and it still gives a signal to noise above 40, which is extremely usable for this data. that will be well needed, so we don't need the 10 seconds. But with this, we actually want to save the individual frames to get that actually faster sampling rate. So we want that 8.7 sampling rate over the 30 seconds. The 30 seconds wouldn't be bad, but we want to make use of the fact that panic is on a 2.2 meter, which means we can have a much faster sampling rate. So we would like to have to be able to save the data so that we have that 8.7 second frame sampling rate. But yeah, so that is the general setup with these exposures that we have proposed for. So I do have a couple of questions since I was doing stuff with the OT data earlier. So I don't know if you guys want to ask yours first or if I should ask mine.
I have a comment and a question.
Sure.
Yeah, the comment is if you want 10 seconds, and it's very important to have the 10 seconds, you can then, in the OT, we said is a multiple of 2.9 seconds that you can choose or you can do. So if you go for example 12 seconds, then you will get 11.6 exposure time.
Okay, that's good to know. Yeah.
Yeah. So when you introduce 10 seconds and you don't get the 10 seconds, then you can introduce a little bit more until you get something closer to 10. This is the comment.
Yeah.
Okay.
Okay. Yeah. The question is, you are interested in the K-band.
Yeah.
Are you interested in a narrowband filter, or the broadband filter is what is used for you? Useful.
Either should be okay. I think that's more just going to depend on the other infrared telescopes that we have time with, which I believe are all
Yeah.
using the broadband K-band filter.
Mhm.
So we would want to just match that so that it's like
Okay.
the same wavelength range. So we're not introducing some extra reason that might cause the brightness to unexpectedly shift
Mhm. Okay.
when
Yeah.
switching between the telescopes.
Fine. Great. Thank you.
Yeah, but then which filter is going to use? K short, KS.
Yes, that's what I have currently put in the OT is the KS filter.
Okay, KS.
KS.
Okay.
Are you interested in the complete field of view?
I have the set it up, yeah, as like a full frame, but I wasn't sure because that's going to depend on we have like a data pipeline here that we use for our relative photometry that uses comparison stars that are also in the field of the images that we see. So I don't know how large the subframe field of views are in like arc minutes.
You can choose. So the maximum field of view is 27 arc minutes, and you can do sub windows, any size inside.
And then
Okay.
if you reduce the size of the field of view, you can get less exposure time, right?
Yeah. Yeah.
The
This is
minimum
it.
exposure time is 2.9 seconds. But if you reduce the field of view, for example, in the middle, and then you can also reduce the exposure time, the minimum exposure time, right?
Proportionally, yeah.
Proportional. Right.
Okay. Yeah.
And
And then
also, sí, good.
oh no, I was just gonna say because G29 has a very sparse field for comparison stars, so it has to have a field of view that's at least I think it's like 4.5 arc minutes by 4.5, so we can actually get some of the comparison stars in.
Wow, 4.5.
Yeah, yeah.
Wow, that is too smaller because we have 26 are minute. And you
Yeah.
said 4 are minute.
It needs to be at least 4.5. So 26 would work well because it
Okay.
would include more comparison stars, but it needs to be at least 4.5. Yeah.
Okay. Good idea. And also you say that you want exposure time of 5 seconds or 10 seconds in position. And then move, or because you say that you
30,
want
30 seconds per position. No, 10 seconds per frame.
yes, and then multiply by 3 frames. And then
Yes.
you are going to be in the position on total of 30 seconds, right?
That was the idea. So I wasn't sure with setting up the OT how exactly
Yes.
the dithering was working, like if it was an individual frame that it differed between, or if it was every like exposure that was dithering between.
Okay.
But it should be with since we are using the comparison stars, as long as the G2938 and the comparison star is always in all of our imaging, our pipeline that we have here is able to divide the G29 light curve by the comparison star. So we don't necessarily need dithering with what is set up since we're just doing the photometry. But I can also set up the dithering to avoid
Yeah,
some of the.
but this the thing that we explained about the near infrared that is necessary to do the dither because if not you don't get a good sky just to subtract, right? Because the
Yeah,
sky in near infrared is so variable. You cannot be in a position all the time, and then
yeah,
just maybe in 10 minutes or maybe 20 minutes, just move to take a sky and then come back in the position. That is not a good idea. It's better to have with your target just to make a dither, taking your target, just to get more count, but at least to have a good sample of possible sky, right?
Okay, yeah, I have it set up right now to do like a 3 pattern dither in the OT, so it's doing like a triangle.
Do you play a bit with the OT?
Yes, a little bit, but it's mostly just messing with like the dithering and trying to get
You
like
can
number exposures
you
and
can
stuff.
save in your laptop or in your computer, and you can.
I don't have it on this computer. It's on my research computer, which is at the university right now, because
Okay.
this one's a Mac, so it doesn't. I didn't wasn't dealing with it on, but I have
But,
done with it.
do you need some I don't know, explanation online right now? If you
Then
have
maybe.
question?
Oh, do I have any questions regarding that?
No, if you need some live demonstration with Antonio, with the OT.
I don't think so. I think I understood. I think I
Okay.
was getting through it pretty well. Yeah.
Sí, Anna.
Perhaps, can you hear me?
Yes, perfectly.
I have to leave in a couple of minutes. I'm very sorry, but thank you very much. That this was very, I think, interesting and illustrative. Perhaps could it be an idea that you save your OT simulations, the ones you have already, and perhaps send it to Jose Miguel or to Anna. They have a look and guide a bit just in case, because our observations start on the 17th. They are
Yes.
quite early. And at least 1 week before, it has to be ready to send to the observers. So I don't know if this is a possibility.
Yes, of course.
When you get back to your other computer and have another look with the OT macro and send it back and they check it. I think double check. I'm sure you have understand it perfectly well and your simulation is okay. But I am from the old way school of doing things. I would rather prefer a double
I think
check
that's definitely a good
before
idea.
the observing. Okay, so thanks, Anna, thanks, Jose Miguel, thanks, Concepcion, because that is going to send you the simulation for you to check. Thank you.
Okay. Thanks.
Thank you.
Okay.
Thanks to you. And also, are you going to use the pipeline of Panic? Do you have a look about the quick look, and also when a quick look, like you are not going to be in the observatory, but at least the pipeline, are you going to use that?
I looked at it a little bit, but that was definitely more confusing to me because I did not necessarily understand when I was reading through it because it threw me off because it seemed the fact that it seems like you're just using the terminal and going into the computer when I was reading it just threw me off a little bit when I was trying to read. But we have a pipeline here that if we are able to get the individual like calibration frames and the scientific imaging, we would be able to reduce it and it would be able to do the like photometry throughout the entire night at once for our star. So if, yeah, so we definitely were hoping to use our pipeline as well, but I do know that we would require bias frames, which when I was dealing with the OT, I did not necessarily see a way to get bias frames. So that might throw a wrench in it.
Anna?
But if I understand it correctly, your pipeline is quite automatic and the infrared reduction itself, it will go on and you get the magnitudes, right? So perhaps it is an idea, at least for the first time, to try to check both because you are going to give us, well, I mean, you are going to give us, if we use the pipeline, we are getting a result. And on that, you can do differential photometry, whatever we want or whatever we need. But I personally would think it would be a good idea to, again, double check and see how it works. This will be good for the project, and I think it could be good for Panic as well,
Also,
because
Yeah,
the most
indeed.
input you get from the different projects, the better
yeah.
for further
Yeah.
future refinements, right?
Yeah.
So I think we I think we will have a look into the pipeline production when the time comes. And you go on with your online or local production methods anyway. But I think a comparison it would be good.
Yeah.
That's
Yep.
I completely agree. I think it definitely is a very good idea to do the double check, because for us it will be very useful. Definitely.
You have to excuse me, but now.
Yes, don't worry, Anna.
Sorry, I have to leave.
Yeah.
No. Thanks a
Thank
lot
you.
to
Thank
be
you very
there.
much.
Very
See
much.
you next
Okay.
time.
Thank you.
See you next time.
Bye-bye.
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 Bye.
Bye-bye. Always remember facts that the infrared reduction also is a bit tricky, because you have a lot of frame moving, but a lot of, yeah, and the magnitude of the file and of the mega are quite bigger, right?
Yeah.
I don't know if Jose Miguel wants to say anything about the special reduction with infrared.
Zach, what is the strategy that you follow with the other infrared observations? Because you mentioned there are more in your project. There are more infrared observations.
Yes. So actually, so me and my advisor, we have most of our experiences with optical observational data. So this is the first time we're going to be dealing with like infrared photometry and also a little bit of spectra as well. So our idea though was we were going to use the data pipeline that we use for our optical photometry, which takes in bias, dark, and flat frames in the filter, and then science imaging in that filter, and then does all the data reduction and as well as the relative photometry for the night. So we were hoping we'd be able to apply that to the infrared photometry as well, since we would have, as long as we get the flats and the stuff, the calibration frames, it hopefully wouldn't necessarily be too different to run it through the same data pipeline, because the pipeline doesn't necessarily care about specific filter or whatever, because as long as you have the flats for the same filter, it should work well.
So, but still, you didn't try with infrared to reduce infrared images with this.
Yes, we have not tried that yet.
You would, Then I recommend, I strongly recommend that you try the pipeline of Panic, because this could be a good check of your of your procedure. No, how do you want to do? Yeah,
that's very good. Yeah, a good. I double check idea. Yes.
Yeah.
Just one thing, in infrared you don't have bias, because you cannot take a frame with zero exposition.
Okay.
We don't have a shutter, and then always we play with darks, right? With the same exposure time. Bianak know a lot about that. With the same exposure time and repetition that the sign frames. Normally you take the darks, not the bias, right?
Okay.
But anything that you want to ask, just we are here, because the object is always take the good signs for you.
Yeah. I did have one quick question related to, since the exposures are like subframes and then exposures, right? And I know that Panic's like saving like an individual exposure with all of the subframes as one fits? Or like how is the fits kind of saving the data? I guess it was part of my question.
Jose Miguel, I don't know if you want to ask about and to answer the way that you can save the data.
I'm not sure. Well, I'm not sure if I have understood the question. You mean how the sub windows are saved?
I'm just wondering if I click that I want the individual frames saved, so it's like an exposure with multiple frames, that not the subframes, just like a general frame.
Yeah.
Yeah, and I want them individually saved rather than integrating across all of them. I was just wondering, are they saved as a single like large fits file with multiple sub files, or is each individual frame saved as its own fits?
Yeah, about cube, raw data, and
you can the individual frame you get the individual frame in one single fit file, but in the case of no integrated, you have a cube with
Okay.
one image for one array for each frame, but in one
Okay.
single fit file. There is another option to have the separate fit file for each frame, but well, I think if I remember well, it's not currently implemented in the OT, but it's available at GEARS, the low-level software.
Okay.
Well, but I think for you is quite enough with the cube. If
Okay.
I
But
don't
does the
know.
cube
I don't know
have
if
the
you see
times as
the
well?
I shared your presentation of yesterday, Jose Miguel. Are
no,
we? No, I'm not sharing. Nobody sees my. No.
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 Okay.
You can, Conchi, you can.
I'm not sure.
Now.
What do you see?
It's coming.
Nothing.
Now
Now,
we
now,
see
now.
your whole
Your desktop.
desktop.
Ah, see. Okay, is the slide where you were? I don't know if you see now.
No, just
Yes,
now.
yes, we see
Thanks.
now.
Yeah.
Okay,
Exactly.
is this what we are talking about?
Yes.
This is
Yes,
from your
I think so.
presentation of yesterday. So for
Yes.
visualize for him. Okay. Yeah. Sorry. Just
So,
to visualize. Yeah.
yes, I will. Sorry, I will hop in for a bit. If I understand you correctly, Zach, I mean, you don't want integrated, you want a cube where all
Yes.
the images are saved individually, but in one big fits file, right?
Okay.
Yep.
And then related to that, does
Mhm.
Panic does it have like a related cube that holds all the timing information to those exposures, or?
Good question. Well, I think no, you only have. I will need to check, but I think you only have the beginning and the end of the exposure time or your
Okay.
exposition. But well, I will need to check, but but I think that you only have when the exposition start and when the exposition end, but not
Okay.
the precise time for each frame.
Sounds
It's
good.
a
Okay.
good question, but well, let me check and I let you know.
Sounds good. Thank you.
Okay. Any more questions or should we?
I think
Yeah,
that's
we
all
can.
the stuff I
Oh.
had for now.
Okay.
Okay, thanks a lot. Just I think, Conchi, just that if you don't mind, send as soon as possible your macro, your
Yes.
Observation. Yeah.
observation strategy,
We'll do that
just to
when I
check
get to
began the
campus.
observation October, right? Any question?
And-
We are just on disposition, right? You're okay, Conchi.
Yeah. So thank you very much to all participants. Paso a español. Ya vamos a cerrar. Vamos a cerrar. No estoy.
Sí, se te ve y se te oye.
Vale. Vamos a cerrar ya la parte de recording, la parte pública de esta sesión. Muchas gracias a todos por vuestra participación. En cuanto tengamos los vídeos disponibles en la página web de Calar Alto, bueno, en la página web de Panic, os avisaremos con un mensajito por la SEA. De nuevo, darle las gracias también especiales a los profesores que hemos tenido de lujo, Ana, Bianac, Antonio y José Miguel. Y por último, también a la RIA, Begoña, por esta plataforma tan estupenda. Y bueno, pues adiós a todos, larga vida y prosperidad y nos vemos pronto. Que se quede, bueno, para tú, Begoña, que yo no puedo. Gracias.